Mean and weighted mean. Okay, so we have 4 exam scores here. X1 is 75, exam 1 75, exam 2, X2 73, X3 82, X4 is 100. So the mean is represented by X bar, and here's the formula for it. For 4 exam scores, we have the sum as k goes from 1 to 4 of xk all over 4. So this Greek letter capital sigma means sum, and we're going from 1 to 4. So it's x1 plus x2 plus x3 plus x4 all divided by 4. Okay, so the first exam score is 75. 75 plus 73 plus 82 plus 100 divided by 4. And let's see, 5 and 3 is 8, and 2 is 10. 31, 1 and 7 is 8, 15, 23, 33. 330 divided by 4. 4 into 330. 4 doesn't go in 3, goes in 33 8 times. 8 times 4 is 32. Remainder 1, go down to 0. 4 to 10 goes 2 times. 2 times 4 is 8. Remainder 2, add a decimal point and a 0, bring it down. 4 into 20 goes 5 times. 5 times 4 is 20. So the mean is 82.5. Okay, so in courses, sometimes it's common to weight the final exam more than the other exams. So let's find the weighted mean. And here's a formula for the weighted mean. This formula applies if the weights all add up to 1. So Greek letter sigma meaning sum again, and we have 4 scores. We're going 1 to 4. So it's each exam score times its weight. So so it'll be x1 times its weight, x1 times w1 plus x2 times w2 plus x3 times w3 plus x4 times w4. So here we're given the first 3 exams are each weighted 20%, and the final exam is 40%. So we'll have the same scores we had before. We had first score is 75, and that's weighted 20%, which is a decimal is 0.2. And then the second score was 73, and that's weighted 0.2. Third score is 82, and that's weighted 0.2. And the last exam is weighted 40%, or is decimal 0.4, so it's 100 times 0.4. So this is going to be 15.0, 0.2 times 73, I think 14.6. 82 times 0.2, 16.4, and then 0.4 times 100 is 40.0. Okay, so we want to add up these numbers here. Okay, so 6 and 4 is 10. Put down the 0, carry 1. 1 and 5 is 6. 4 is 10. 16, put down the 6, carry 1. 1 1 is 2, 3, 4, 8. So the weighted mean is 86.0, or just 86. That's with this weighting system. If the first 3 exams are each weighted 20%, and the final exam is weighted 40%. Okay, so not all instructors weight exams the same way. Maybe a different instructor has a different weighting system. So let's see what happens under a different weighting system. Let's say the first 3 exams are weighted each 10% now, and the final exam is weighted 70%. So again, it's the sum, the sigma means sum. As k goes from 1 to 4, we have 4 exams. Each exam score times its weight. So the first exam times its weight, second exam times its weight, third exam times its weight, fourth exam times its weight. So the first exam is 75, and that's times 0.1. Second exam score was 73, that's times 0.1. Third exam score is 82, times 0.1, and the final exam was 100. Its weight was 0.7. So 0.1 times 75 is 7.5. This will be 7.3, 8.2, and 70. So 5 and 3 is 8, and 2 is 10. Put down this 70.0 if you want. Carry 1, 1, 7 is 8, 15, 23, 93. 93.0 or just 93. Okay. So that's under that weighting system. Okay, so here's a third weighting system. Find the weighted mean if each of the 4 exams are each weighted 25%, or is the decimal 0.25. Again, we have 4 exams. Each weight is 0.25. So it's sigma is summation is k goes from 1 to 4. Each exam score times its weight, x1 times w1 plus x2 times w2, and so forth. So we're going to have first exam score is 75 times 0.25 plus 73 times 0.25 plus 82 times 0.25 plus 100 times 0.25. Okay, so 75 times 0.25, 5 is 25, 2 times 7, 5, 35, 37, 150, 5, 7, 8, 18.75, and 73 times 0.25, I don't know, 15, 36, 46, 5, 12, carry the 1, 8, 18.25, 82 times 0.25, 10, carry the 1, 8 times 5, 40, 41, 4, 16, 0, 5, 2, 20.50. And okay, so if we add these up, we have 18.75, 18.25, 20.50, and 0.25 times 100, 25.00. And 5 and 5 is 10, put down 0, carry the 1, 1, 7 is 8, 10, 15, carry the 1, 1, 8 is 9, 17, 22, carry the 2, 2 and 1 is 3, 4, 6, 8, 82.5. 82.5. And one thing to notice here is that this is the same as we got for Part A. The regular mean is 82.5, and here, notice here that each exam is weighted the same. So if all the exams are weighted equally, we'll do a proof later, but if all the exams are weighted equally, then the weighted mean is the same as the regular mean. Okay, so we'll do another weighting system here. Find the weighted mean if the first 3 exams are each weighted 1 and the final exam was weighted 2. This time the weights do not add up to 1, so we need to divide by the sum of the weights. So the formula is the sum, and again we have 4 exam scores, so if the sum goes from 1 to 4, k equal 1 to 4, each score times its weight, but we also have to divide by the sum of the weights. That's the sum as k goes from 1 to 4 of wk. So it's the numerator, each exam times its weight, x1 times w1 plus x2 times w2 plus x3 times w3 plus x4 times w4, and the denominator, we're just adding up all the weights. What w1 plus w2 plus w3 plus w4. Okay, so the first exam score is 75, its weight is 1, and the second score is 73, its weight is 1, and then we have 82, its weight is 1, and 100, its weight was 2. And we want to divide by the sum of the weights, so it's 1 plus 1 plus 1 plus 2. So this will be 75 times 1 is 75. So 75 plus 73 plus 72 plus 200. And 1 plus 1 plus 1 plus 2 is 5. And then 2 and 3 is 5, and 5 is 10. Put down the 0, carry 1. 1 and 7 is 8. 7 is 15, 22, 42. Divided by 5. 5 and 2, 420. 8 times 5 is 40. I don't know, maybe that's this is supposed to be 82 here. 82 times 1 is 82. So let's try this again. 3 and 5 is 8. 10 carry the 1. 1 7 is 8. 15, 23 would be 43. 43. So 8 into 43 goes, 5 into 43 goes 8 times. 8 times 5 is 40. Remainder 3. Bring down the 0. 5 into 30 goes 6 times. 6 times 5 is 30. So this is the weighted mean under that weighting system. Okay, so let's go back to what I said before. If the exams are weighted equally, then the weighted mean is the same as the original mean. We had an example 1A. We had the regular mean of 82, and then example 1D. We had the exams all weighted equally, and the weighted mean was also 82. So we want to prove that that will happen for any data set. We want to prove that for any data set, if the scores are weighted equally, and just to make things simple, we'll say the weights add up to 1. So if the scores are weighted equally, and if the weights add up to 1, then the weighted mean is the same as the regular mean. So in symbols, what we're trying to prove using the sigma notation, the sum as k goes from 1 to n. Well, we had 4 exam scores, but this theorem is going to be true for 5 exams or 6 exams. It doesn't matter how many exam scores. Sum as k goes from 1 to n of xk times wk. So n is the number of exam scores, is equal, that's the weighted mean, and this is the regular mean here. The sum as k goes from 1 to n of xk all over n. So we're going to start with the left side and try to manipulate it to get it equal to the right side of the equal sign. So, okay, so the summation as k goes from 1 to n of xk wk was the first exam times its weight, plus second exam times its weight, plus etc. The 3 dots mean etc. Plus the last exam times its weight. And that's by definition of sigma. Sigma means sum. That's just what it means to be the sum. And so, but if we have n exam scores and they're all weighted equally, then each weight is going to be 1 over n. It's just, if you think about, well, I'll just write this out now. So the first exam score times 1 over n, plus the second exam score times 1 over n, plus etc., plus the last exam score times 1 over n. If you think about, like, say, dividing a pizza among 2 people, if you want to divide it equally, each person will get 1 over 2 or one half of the pizza. If you're dividing it equally among 3 people, then each person gets 1/3 of a pizza, or 1 over 3. If you're dividing equally among 17 people, each person will get 1/17, or 1 over 17. So in this case, we're dividing among n people. Each person gets 1 over n. So in this case, we're not dividing pizza, but we're weighting exam scores. If they're weighted equally, then each weight is going to be 1 over n. So this is because scores are weighted equally. Okay, so so now we have a common factor of 1 over n. We can factor that out. So we can write this as x1 plus x2 plus etc. 3 dots mean etc. plus xn, and the whole thing is times 1 over n. So this the distributive property of multiplication over addition, or you can just say factoring, common factor of 1 over n. You can say factoring or a distributive property. We're kind of using the distributive property in reverse. When we do factoring, we have a common factor of 1 over n. And then we can go back to sigma notation. So we can use sigma notation to represent the sum. So this is equal to the sum as k goes from 1 to n of each exam score times 1 over n. So that's by definition of sigma again. That's what it means to be a sum. Okay. And then we can use the rules for multiplying fractions. Let me try to make some more space here. So this is equal to use the rules for fractions. We can make any expression into fraction by putting it over 1. And then the way you multiply fractions, you multiply the numerators, multiply the denominators separately. So this is the summation k equal 1 to n xk all over n, which is the regular mean. So that finishes the proof. Okay, so and that concludes this presentation.